So, my name is Raphael Linker. I'm from the Faculty of Civil and Environmental Engineering, and I'll be presenting today's activity we have now within the Center of Digital Agriculture that was established about a year ago and brings together researchers from Technion, Ben-Gurion University, and Hebrew University, all together with something like 15 different teams from engineering, plant physiologists, AI people, everything in between. So very briefly, the ultimate goal of this center is to apply AI to understand the behavior or performance of crops so that we can increase yield or reduce the use of resources or whatever, increase food production and so on. So that's the work package for this year. And in order to be able to use these AI models, of course, we need a lot of data. And the only way to actually get the sufficient amount of data is to use automation for data collection, because it's not realistic to have field trials and to send people in the field to take measurements 24/7. So the project itself is looking at field crops and also greenhouses. And of course, there are people who can, let's say, plant physiologists and the end users. Our team is working on the field crops monitoring, so I'll be focusing on this part. So this is what is typically done for monitoring of phenotyping of field crops. Huge systems, these huge countries that, of course, are very expensive to establish, to maintain. There are also some limitations that, so you have all the sensors here, for instance, the cameras and so on. And so you get a lot of information, but you still within 1, 2, 3 meters of the crop. You cannot actually take measurements on a specific leaf, which is interesting for to study various processes. So our approach is to use much smaller platforms, such as this one here, that will travel within the field. So this would be like an over-the-crop platform on which we are installing a lot of sensors and robotic arms so that we can sense proximal sensing like before, so from a distance of 1 or 2 meters from the crop. But we can also use the arm, the gripper, to actually take measurements on the specific leaf or to touch the leaf for future analysis if we want. We want to install soil sensors so that you're not only looking at the crop itself, but also what is happening in the soil, for instance. Small drones to get information about the surrounding of whatever you are measuring or monitoring with this specific sensors. So, and the idea is that this platform will travel continuously within the field and scout the crop continuously. So this is one of the platforms that we have. We also have this one, which is not over the crop as this one, but just within the crop or on the side of the field. And again, the idea is to also install sensors on this platform. So very briefly, one of the main tasks is to use a robotic arm to replace the human that would go and take measurements on the leaves. And you see here a number of typical sensors that we go and clip on the leaf in order to measure gas exchanges, temperature, whatever. The measurement is different, but the idea is always the same, that you have to come and clip your sensor to the leaf. So what we want to do is to basically attach these sensors on a robotic arm and have this done autonomously. So there are different kind of challenges. The leaf should not be picked randomly. There are actually protocols, and the protocols depend on which crop you are monitoring. So it's different if you have a tomato crop or potato or wheat. So you go to the first leaf from the top on the right, or no, the second one from the bottom on the left. So you have to be able to identify the architecture of the whole plant in order to pick the right leaf or leaves, maybe several ones. You of course to extract the exact pose of the leaf in order to paint the sensor. To get there without making any damage to the plant. Since we want to use these existing sensors, in some of them the aperture is very small. Like this one, when you open it to get to the leaf, you open it maybe 2 or 3 millimeters. So you have to be very precise in order to actually catch the leaf itself. Also, another important aspect when we look at the integration of the whole system is to validate the measurements so that you make sure that you actually get a valid measurement and you didn't miss the leaf or catch a brown spot or something like this, so that a human would see that yes, this is not a correct measurement and do the measurement again. So we have somehow to teach the system to do something similar in real time. So very briefly, what we did, so we created this 3-dimensional model of a tomato crop, something called a plant factory, which is a software that allows you to build this model, which is parametric with different values of all different parameters. You can generate hundreds of thousands of crops or plants. They will all look like a real tomato plant, but they will all be slightly different. So we can use that afterwards in a gazebo to see the interaction with the robot, see how to bring the gripper or the sensor to the correct pose and to actually perform the sampling. So this is what we did here. This is the simulation in gazebo. So we have one camera, for instance, that's fixed here, another one in the hand of the arm, and then what you see the projector of what we see. We put this together in gazebo with the model of the plant, and here's a short simulation. Okay. I don't know. Anyway. Oh, no. Okay, so let's keep this again. So this is what we wanted to look at the end. Here we have the arm with the sensor, which is here, and if you go, you see here, catch the leaf, close the gripper from the measurement. It works in simulations. This is not yet with a closed loop with the servo. This is just repeating something that we did manually, just to illustrate. But this should be the final. It's a final product of this smaller sub project within the larger one. And we would want to have different kind of sensors that we can connect here to this grid. With the same kind of model from the plant factory, instead of having just one plant, we can of course create a whole field, and then we can use the same models to now form navigation of the platform. So this is another aspect of the work. Navigation, we have the usual suspects that we that usually use for navigation in terms of sensors. There is the low-level navigation, which is just traveling within the road without driving over the crop. But there is also some more some higher-level decisions that need to be made, which is where to go, which crop to sample at which time. So it's not just not to travel over the crop. There's some other issues as well. One other element is a small UAV, which could work together with the ground-based platform, so that whenever we take a measurement, which is very local with these sensors, we also want to have an idea of what are the neighboring plants, so that we can see what is happening. And the way to do this is to use a small autonomous UAV that uses basically the ground platform as a landing and takeoff platform. Goes to maybe 10, 15 meters, so not very high, so that we can just get an idea of the, say, 5 by 5, 10 by 10 meters around the spot that we are currently monitoring with the more advanced local sensors. There are many issues in terms of sensing. So we have different kind of measurements that we can make on the leaf itself. So all the sensors that I presented before, there is all the synchronization and the analysis. We also have some proximal sensing, so not just touching the leaf, but at the same time, or in parallel, we can use different imaging systems that can be multispectral, hyperspectral, terahertz, polarization. All this information again has to come together so that we can feed the data database for AI analysis. In addition to the canopy itself, we also want to monitor the subsurface, basically the root zone, so that we can get information about the soil, the water moisture, maybe even chemicals in the soil, and most importantly, the root density and maybe tubers, if we're talking for instance for so that we can actually see the tubers or at least get an estimate of the density within the soil. So this also needs to be integrated with the large problem. So to keep it short, there is a lot of very wide range of topics and different levels. It can go from undergraduate projects to PhD or postdoc. There is a very wide range of topics, different levels. Some are much more technical, otherwise some other ones are much more, I would say, algorithmic. So if anyone is interested in, I would say, real life topics where maybe the common element here is that these systems are very uncontrolled and complex, and this is not lab work. This is a real work. So if anyone's interested in such a project, please feel free to contact.